to above the x-axis, which occurs at x equals what? So where does it go from being below the x-axis to being above it? At -2, we're at the bottom, we crossed over to the top. Where did it change? -2. Now we're on the top, we crossed to the bottom, right? We already did that one, that was a max, right? Positive to negative. Now we're going from being below to what? Above, so we're going from negative slopes to positive. We're going from decreasing to increasing, so therefore we have to have a maximum, right? So it occurs at two places, -2 and what? 3. Easy? Yes? Let's see if we can answer these last two questions. It says if h of -1 equals 1/2, what is the equation of the tangent line drawn to the graph of h at x equals -1? What do I need to write the equation of a tangent line?
Point of tangency.
Point of tangency
And slope.
and the slope of the tangent line. Okay? So, which of those two do I know?
Point of tangency.
I know the point. What would be my point?
-1 and 1/2.
-1 comma half? Very good. Where did we get that from?
The question.
From the question, right? h of -1 equals half, right? And they want the tangent line at what? -1, which is the same x, right? Okay, how do I find my slope of the tangent line?
The graph.
Use the graph, right? Because we want h prime of what?
Negative.
Of -1. So do we have the graph of h prime? Yes. So let's use it. What's the derivative at -1?
5.
5. Beautiful. So now can I write my equation of the line? Let's do it. What is it? Y minus half equal 5 times x plus 1. Beautiful. Super easy? Right? How about the next one? If h of 2 equals -3, what is the equation of the normal line? Órale, how do we do that one? Do we still need both of these things?
Yes.
Yes, so we still need the point and the slope, and then we can use that slope of the tangent line to get the slope of the normal line, right?
Yes.
So what's my point going to be? 2 -3, and what's my slope going to be? H prime of 2, right? So we go up to my graph, and I go to 2, and it tells me the slope is what? Negative. But that's not the one I want, right? I want the slope of the normal line, which is going to be what? Half, right? The opposite reciprocal. Very good. So what's the equation of the normal line? Y plus 3 equals 1/2 times x minus 2. Beautiful. Kindergarten stuff? Yes?
For reminder.
We're getting a good idea of how to interpret a derivative graph? Yes? Alright, we're going to practice a little bit more, okay? I have 2 more examples to practice with before I give you your assignment. Alright? It's very important, okay? You need to be able to change your way of thinking depending on what graph you're given. Yeah? Alright, so let's look at this next graph. What is it the graph of? F of x. So is this a derivative? Is this the list of slopes? No. Okay, so am I going to label it positive slopes, 0 slopes, negative slopes? No, this is my original graph. To figure out the slopes, I need to imagine the what? I need to imagine the tangent lines, right? In order to figure out the slopes of the tangent lines. Okay? Yes? We're not going to draw them, okay? Now let's look at the first question. What do they want us to do? Approximate the value of f prime of 4. So what does that mean? Very good. So in English it's asking me what is the slope of the tangent line at 4. Okay, so let's go to 4. Okay, 1, 2, 3, 4. Where am I on the graph? Right there, right? It's not an exact point. They want me to estimate the slope at that particular point. So what would the slope of the tan line be there? Let's come up with an approximation. What do you want it to be? Maybe this point right here? Would that be an okay tangent line? Sure? Okay. So what would that slope be? 1, 2, 3 over 1. So what would f prime of 4 be? Approximately 3, right? That was my approximation. Some of you were using a different one, right? Yeah? Are any of us wrong? No, because they're approximations. Unless you were like totally off axle, like you put negative something, right? Yes? Then we would know like, yeah, that's totally wrong. Alright? Put away your phone. Let's listen. How about this next one? At what values of x is f prime equal to 0? So what is that one asking? Very good. So if f prime of x equals 0, what do we know about the original function? Less than 0. And we know the original function has to have what? A relative max or min. Right? So where do I have my relative maxes or mins on this original graph? X equals what? -4 and 1 and 5. Very good. If I drew tangent lines at each of those places, Daniela, they would all have a slope of what? Of 0. Good? Easy? Alright. On what open intervals is f prime less than 0? If the derivative is less than 0, then what must be true about the original function? It's decreasing, right? So let's write that down. If f prime of x is less than 0, then f of x must be what? Decreasing. And where does that occur? At what intervals?
-4 and
-4, right? Starts decreasing here, because here it's going up. And then it's decreasing from -4 to 1. Good. Union. 5 to infinity. Easy? Alright, let's look at the next one. On what open intervals is f prime of x greater than 0? What does that mean? That means it's positive, right? So if the derivative is positive, then the original function must be what? Increasing. Well, I need to know that so I can find the answer to that question using my original graph, because that's what I'm given, okay? And where does that occur? Negative infinity to -4, right? Union, where else does it increase? 1 to 5. Is everybody with me? Yes? And I'm providing the justification through my answer. Okay, so I'm telling them, if this is greater than 0, then f of x must be increasing. My justification is using what I'm given. Okay, I'm using the graph that I have to justify the answer that I'm picking. Do you understand? Okay. Always remember that. So if they give you the derivative graph, you need to justify using derivative information, using the graph that's given. Alright, number 5. At what values of x does f prime of x go from being below the x-axis to being above the x-axis? So f prime of x, that's the what? The derivative. When the derivative is below the x-axis, what do we know? So f prime of x is what? Negative, right? And when we go above the x-axis, then we know f prime of x is what? Positive. Okay, but that's in reference to the derivative, right? Do we have the derivative graph up there? No. What is it that we have? The original. So we got to think of it as the original graph. So if the derivative is negative, what do we know about the original function? Is decreasing. And over here it's what? Increasing. So basically, using the original graph that I have, I need to find where it's changing from what? Decreasing to increasing. So let's look up there and see if we can figure that out. Where is it changing from decreasing to increasing? What's happening here? Increasing. Now it's what? Oh man, that was the opposite, right? So we don't want that one. Okay, so now we're decreasing. And now we are? Oh, so did it change from decrease to increase? Where did it change?
1.
At x equals 1. Is that what we wanted? Yes? If I had the derivative graph, the derivative would change from some what? Negative number to some positive number. It would go from being below to being above, like the one we just did on the previous example. Yes? Okay, cool. So let's write our answer, okay? So, f prime of x changes from negative to positive at what? X equals 1, good. And what would be our justification? We always have to use the graph that we're given. So because we're given the f graph, so because f of x, what? Changes from decreasing to increase. And I'm using the different colors so it could match back up to up here what I wrote. Okay, this is just my thought process, and then this is the nicer way of writing. Good? All right, so let's use that thought process to answer number 6. At what values of x does f prime go from being above to being below? So now they want me to go from what? When the derivative is above, the derivative is what? Positive, and when it's below, it's what? Which means my original function is what? Increasing, and it's changing to being what? Decrease. So let's look at the graph and figure that out. When is it going from increasing to decreasing? Because I'm using the original graph actually. Okay? So what's happening here? Increasing, and then? Oh my God, so did it change from increasing to decreasing? Did it change from positive slopes to negative slopes? Yes. Where did it change? -4, right? We have a maximum, right? Where else is it going to change from increasing to decreasing? At 5, okay? Right there, right? Good. Right there. So f prime changes from positive to negative at what? X equals -4 and 5, right? Why? Very good. Because the original function changes from increasing to
Mr. Science,
Yes, sir.
can you submit your attendance for second block, please?
Today?
Yes, it's very urgent, please.
Okay,
Second
sir.
block.
You got it. Second block, let's see, who's absent?
You go, Mr. Science. Stick it to the man. Today.
Well, it's 'cause usually they'll call for like an old one.
Sir, Jesus is absent.
Jesus?
No, I'm just kidding.
Jesus absent?
Yeah, I'm just kidding.
He was absent?
No, he's absent.
He was, right?
Yeah, he was.
You can't be jumping around like that.
I remember seeing him.
It's in here, it's in the back.
He's a what?
We call him that.
It's like a la maíz. What? Where'd that come
You
from?
know that guy? You need to help him, man.
He's my best friend.
He's struggling. Tutor him, okay, Alan? You like him or what?
Everybody picks you.
I know, but no.
He's your
That's
best
so
friend?
funny.
No?
Got a pretty good thing in
He's
the
your ex-boyfriend?
February 7th.
Next.
February 7th? Is that your anniversary? Or?
No.
Yeah. Yeah, middle school.